our topic is talking about the application of the Newton's laws of motion. And this laws of motion will be applied to the problem on the double inclined surface system problem. Now, the requirement of this topic is the viewer should have the idea on the three laws of Newton's, the first law, the second law, and third law. Then another requirement is you should have the idea on calculating the amount of friction between the two objects. Okay, so the problem is a double inclined system. We have the mass A whose mass is 100 kilograms and mass B having 50 kilograms, and they are both connected by means of cord. Now this cord is massless, and this cord is passing through the pulley, and this pulley is frictionless. There is no friction between the cord and the pulley, but there is a friction between the plane and the blocks. Now the friction in the block A and B is zero point 0. The coefficient of kinetic friction is 0.05. Now the question is, which way will the system move when the blocks are released from rest? So starting from rest, what will be the direction of this block? Whether is it moving towards the left or maybe moving towards the right? And there is also a possibility that this object will stay at rest. Why? Because friction can hold the object. Now, what will we do in order to answer the question which way? That will be question letter A. Now, if the system moves, letter B, how much is the acceleration that blocks? Meaning, whatever acceleration of A will be the acceleration of block B. Then letter C, we are asked to solve how much tension on the cord. So, there are possibilities again. The movement of the system. The system will possibly move towards the left. This is the left side. Then it has the acceleration. And whatever acceleration of block will be the acceleration of the block B. Block A is tend to move down the plane while block B will tend to move up the plane. And whatever acceleration of this, the same direction experienced by the block B. Another possibility is the system will move towards the right, which means that B accelerates downward, down the plane, while A accelerates upward. Now take note, acceleration means if it is at rest, then it will move with increasing velocity because of that acceleration. Another possibility is the system will stay at rest. So therefore, the acceleration is zero. If it starts from rest, then zero acceleration, then the system will stay at rest. Now, how did we know that this is at rest? If the calculated A, if the calculated A is zero, then the acceleration is at rest. Now, if the calculated A is not equal to zero, there are two possibilities. Okay. Now, in this case, we will assume, no, since we don't know yet the direction, so we have to assume direction. So we will assume that the block B will move down the plane while block B will move up the plane. So in other words, we will assume that acceleration A is down the plane while acceleration B is up the plane. So whatever acceleration on A will be the acceleration at B. So we will assume first that the system will move down the plane system or towards the right. Now what will be our action after calculating A. So this is what happened. If A is positive, then our assumption is correct. Now, if A is negative, there are two possibilities. Your assumption is wrong. So then then maybe it is at rest. Then all you need to do is to try another position assumption. You have to assume downward. If the answer is still negative, then say it that the object is at rest. Or if the answer is very close to zero, then the system is at rest. So in this solution, we will assume direction that the system moves towards the left. Now, what will be our first step? This is the step to solve this problem. First is you need to analyze the two blocks. Analyze A and B. Analyzing is to have you have to construct the free body diagram. So first requirement is to construct the FBD or the free body diagram of mass A. Then after that, you have to overlay the object to the axis. I use the positive X down the plane of A because I assume that A will move down. So therefore, the direction I set the direction to be along X. Now perpendicular to that plane will be our y-axis. Now very important to overlay the Cartesian so that uh, we can identify the direction of the forces acting on the masses. So in mass A, the forces are we have the by the way if we assume direction then since this is our direction so therefore the acceleration should be downward so again the acceleration is towards the positive x. According to the second law, whatever direction of acceleration will be the direction of the force. So this is the net external force of A while its acceleration is A. Now remember in second law the net external force is equal to the product of the mass. This is the moving mass multiplied by the acceleration. So, what are the forces acting on mass A? We have the weight. This is the weight of block A. Now, take note that this mass A lies on the plane. So, therefore, there must be a contact. So, if there's a contact, there must be a normal force. By the way, the weight has the direction from this y-axis be equal to theta. Theta is 30 degrees. In geometry, whatever angle this perpendicular to this line will be the angle also of our weight. So therefore, if this is theta, this is also theta in geometry. If you will reduce this angle, if you reduce this inclined surface, then this angle also reduce. Take note that weight is always directed below. So therefore, whatever angle theta here 30, this is also theta. So therefore, we have the direction of the weight of the block A. So again, we have the contact surface, so there must be always a normal force. A normal force is a force acting on the against and perpendicular to the surface in contact. So therefore, the normal force should be towards the positive y-axis. N corresponds for the normal force. Now, since we have the contact, so therefore we have the normal, then we have also the friction. Now, remember friction is an opposing force. It is an opposing force, meaning since we assume that the direction of block is tend to move downward, so therefore, friction should be in opposite direction. So therefore, this should be directed towards the negative x-axis. Okay. Now, another force on mass A is the cord. Now, take note that our mass A was connected with a cord. So therefore, there must be a tension in the cord. That's why we ask this in letter C. What is the tension in the cord? So chord is a kind of tensile force. It is always away. So it is negative. It is along x-axis, but it's negative direction of x. So therefore, these are the forces acting on mass A. We call this as the free body diagram. A free body diagram is a vector diagram showing all forces acting on that particle. So there are only four forces: the weight, the normal force, the tension in the cord, and the friction. Now, if you observe the forces, the four forces, the normal force is lying directly towards the positive y, while the tension in the cord is negative, exactly along the line in the negative x-axis, and also with the friction, it is along the direction of negative x-axis. But our weight is, it has a component along y and along x. So therefore, we must resolve this force weight into its component. So we have the x component, call it as WAX, for corresponds to the component of the weight of the block along x. And this is positive because this is directed towards the positive x-axis. Another component of W is the WAY, means corresponds to the component of the weight of the block A with respect to y. And this is negative because this is downward. So therefore, we already resolved this weight. So the image of A now becomes WEX and WAY. EX is positive component while AY is negative component. So therefore, the purpose of having this one is to segregate along forces along X and along Y. So therefore, next is we have to analyze it along Y and along X. First is we will sum up all forces along Y, and this is equal to 0, Y0. Now take note that we assume that the block A moves downward, so therefore there is no motion along Y. The motion is always along the positive x-axis. So therefore, the net external force along Y should be 0. It must be 0. For the reason that this object is moving only along the along the inclined plane. And our inclined plane is our x-axis. So y must be 0. We call this as for equilibrium purposes because y should be a balanced force. Okay? Then using this equation we can solve for the normal force. We don't know normal, but all we know is the weight. So we can now express our normal force in terms of the weight. So summing up all forces along y, look at the free body diagram. This is the purpose of the free body diagram. The forces along y are the normal force and the component of weight along y. The normal force is positive while the component of y is negative. We need to sum up that two. We have only two values and equate that to 0. So therefore, this will be the result. The positive n minus WAY, the y component of the block weight, and should be equated to 0. So in other words, we can now solve for n by transposing this one. Now, but the question is how much is what's the value of weight of the block along y? In that case, we can solve this one in terms of weight because weight, take note, is mass times the gravity. We have the mass and we have the gravity, so we have already weight. Now, meaning we have to express this in terms of the weight. Now, to solve AY and maybe WAX, WAY and WAX, the component of W along X and Y, we have to construct the force polygon of the component of the weight and its vector. So first is we have to draw the parallel or equal vector of weight along y. Then also with the x component, connect it to the tip of the y component. Then from tail of the y, construct the weight. Or you have to do the equal vector of this weight. Then make it a triangle. So this is now a closed polygon. This will form a closed polygon because AX and AY are the component of W. So therefore, since this is theta, this is also theta. So therefore, this is also 30 degrees. And take note this is y and this is x. So therefore, the intersection angle must be 90 degrees, such that we have the right triangle. So what is AY, WAY, and WEX? Now we can solve this because this is a right triangle. This side is known to be our weight, and the weight is mass times acceleration. And this is 30 degrees. So we have two given, the hypotenuse and the angle theta. So in order to solve for WAY, we have to use the cosine because this is adjacent to the angle. Now to solve for WEX, we use the sine because this is opposite. In other words, WAY is the cosine of is the W cosine of theta. W cosine A of theta. While the x component is WEX is W sine theta. So take note, theta is given again, and the weight is mass times the acceleration. So therefore, replacing in WAY here, replace the WAY with W cosine, then this will be the result. Then transpose this one, and we are solving the value for the normal force. Normal force means there is equal to the weight cosine theta. Next is to use the sum. We will sum up everything along x. If we sum up all forces along y, the sum should be 0. Again, because equilibrium. But if we sum up all forces along x, take note, it is not 0. Why? Because the object moves downward. If you set x, summing up all forces be equal to 0, then you are telling us that A should be at rest. Okay? It's very clear that if you sum up all forces along x, the sum should not be equal to 0. So if it is not 0, what will be the result? The answer is the net external force. This is the net external force, the summation of forces along the A. This is the net external force of the mass A moving downward. So therefore, again, summing up all forces along x, the sum should be the net external force. By the way, take note that there is friction. There is friction. So therefore, by definition of friction, friction is the coefficient of friction multiplied by the normal. Now, since this is coefficient, mu k means the coefficient of kinetic, and n is the normal, multiplying the two will result kinetic friction. There are two frictions, static and kinetic. This is kinetic because the particle is moving. Okay, so now, summing up forces along y. By the way, therefore, since we know already the normal force, then we can say that the friction kinetic is mu k WA cosine theta. Okay, so therefore, we have already the value of the friction. Okay, summing up all forces along x, and the answer is not 0. Remember, the value is the net external force. So therefore, we will sum up all forces along x, then equate that to the net external force, which is the net external force on mass A. So where did we get the forces along x? The answer is, look at the free body diagram. Look at the free body diagram. There are three forces along this x-axis. They are WEX positive, the T cord or the tension in the cord negative, and we have the friction, kinetic friction, and also negative. So we have three. We need to sum up these three, then replace that with the summation of forces along x. Then this one is the second law of Newton formula. Take note, remember that the second law formula, Newton, is net force is equal to the product of the moving mass times the acceleration. So therefore, again, x is coming from the from the free body diagram. So look at this one. WAX is positive, T chord is negative, and we have the friction negative. So these are the forces along X. This must be equated to the net external force. The net external force is the product of the mass and the acceleration. This should be the mass of A multiplied by the acceleration of A. And this is coming from the second law of Newton. So therefore, we have this equation. But we can replace Wx. Remember, Wax is W sine theta. While friction is mu k Wa cosine of theta. So therefore, we can replace that value. So we come up with Wa sine theta minus T chord minus mu k Wa cosine theta minus or equals the mass times the acceleration. Now take note that Wa is what? The mass A times the gravity. So replacing mass A with Wa with mass A times G, so will result mass A times gravity sine theta minus T chord minus mu k mass A cosine G. Yeah. Then we have the cosine theta and equated to mass A times A. So this is now the result. Now if you try to analyze this result, mass A is given. Okay, nothing to worry. G is 9.8 because this is acceleration due to gravity. Theta is 30. So given T chord is what? Unknown. In fact, we asked this in letter C, what is the tension? So therefore, this is unknown. Mu k is given as 0.05. Nothing to worry. Mass A again is 100. G is 9.8. Theta is 30. Mass A is 100 again. Acceleration. This is also unknown. And this is the requirement for letter B. So therefore, this equation is a kind of equation, one equation, two unknowns. So we cannot solve T, we cannot solve A. So in other words, in mathematics, take note that if we have one equation with two variables, there are infinite solutions on that. So we cannot solve the definite solution of A and the definite solution of T chord. So that's the case, leave it as equation 1. Okay, so we will preserve this equation. We still need another equation that involves what? Involves T, chord, and A. So that we have the so-called continuous equation. We need another equation. We need another equation for T chord and that contains T chord and A. So therefore, preserve this value. List it above. So next, what next? Next is to, since we have already done in constructing the free body diagram of A, then we still have another block, the block B. We need also to do the free body diagram and create the same procedure as this. Then form another equation. Now at the bottom of that, we come up with another equation and called it as equation 2. So therefore, do it the same. This time, we will construct the free body diagram of mass B. So then, take note, the mass B should move up the plane. Why? Because we assume that BA moves down the plane. So the mass B should be up. So in that case, the x-axis must be towards or moving up the inclined plane and at B. So therefore, x must be directed towards or upward. And y is the perpendicular. Why is it that we assign x? Again, the purpose of having x here is to ensure that the acceleration is moving along that axis. So we assign that as the x-axis. So therefore, the purpose of having this axis is to ensure that everything, if all acceleration is towards the x-axis. Now in that case, according to Newton, that whatever direction of acceleration will be the direction of the net external force of block B. So therefore, we have already the idea that the net external force will be along this axis. That's why I use it as a positive x-axis. So therefore, next is to construct all the forces acting on the, we have to draw the forces acting on block B. Again, because we have the mass of the block, so therefore we have the weight, we have the weight of the block, and we have the, since we have the contact, then we have the normal, just like what we did before. Since we have this normal force, then there should be friction, because friction is the force in contact. And the normal happens only when there is also contact. So whenever there's a contact, there's normal, there is always a friction. And friction will be directed downward. Why? Because we say that this object will move upward. So friction should be in opposite direction. Then take note that this block B was connected by means of cord. So therefore, there must be a tension in the cord. And this time, this is positive. If you remember previously, T cord is negative because it is directed up the plane of the block B. So this time, this is a positive force. So therefore, we have again four forces, but we need to resolve W because W is not lying along X, not lying along Y. Unlike chord is along positive X, normal along positive Y, friction is along negative Y. So we need to resolve this weight into two components. So resolving, we have W, B, Y, the Y component directed negative, while the component of B along X is also negative. So therefore, we can forget the value or the weight and consider their components so that we can segregate along X and along Y. So therefore, we are now summing up all forces along Y. Same as before, Y should be 0. The net forces along Y should be 0. The reason is the block is moving directly towards the positive x-axis. So Y must be 0. Now, in that process, our forces along Y are the normal force and the W, the component of W along Y. So negative. Then take note that WBY, go back to our previous solution, W component of this WB along Y component is W cosine, but W sine beta, no, beta, because this is the angle beta, this is the angle beta, this is the angle beta. So the Y is adjacent to B, to beta, while X is opposite. So therefore, we can say that WBY is W cosine, while WBX is W sine of the angle beta. So replacing here, WBY, so come up with N is minus WBY cosine. Transpose that to the right side. Okay, then again, same procedure. Friction is coefficient times normal force. The normal force is WB cosine. So this is the value of friction. We need this one because we will sum up later forces along X. So we are done with summing up all forces along X. By the way, the purpose of summing up all forces along Y, we know already that it is in equilibrium, but the main purpose of that is we can solve the normal force. After solving normal force, it is normal is very important to our force, frictional force, because it is mu times n. So therefore, we are calculating the normal force if we sum up all forces along Y. Now this time, summing up all forces along X, we have to ensure that along X there must be unbalanced force. So therefore, if we sum up all forces along Y, along X, the sum should not be 0, same as before. Okay, because this object moves, the block moves upward. So if you sum up all forces along x-axis, the result should be this one, the summation of forces of the block. We call this as the net external force on the block B. So therefore, summing up all forces along X, the result is the net external force of block B. So, what are the forces along X? The answer is, we have the T chord and we have the we have the friction negative, and we have the component of W along the negative x-axis. There are again three forces. So do it summing up all forces, and these are taken from the free body diagram. So the free body diagram plays an important role in dynamics, because if your free body diagram is wrong, then this will become wrong if you sum up everything about x. So there are three forces: W, V wakes, P curve, and we have the negative friction. Then this will be equated to what? To the net external force. The net external force is taken from the second law of Newton. The mass, the product of the mass times the acceleration is the net external force. Since this is block B, so therefore this should be the net external force on the block B. Okay, then replacing values, because we have WBX here, substitute. We have friction, then do it the same. So we come up with negative WB sine beta plus T chord minus mu K WB cosine beta, equivalent to the mass of the block multiplied by the acceleration of the block. Take note, this acceleration is the same acceleration as before. This T chord also is the same as the T chord as before in this equation 1 above here. Why? Because the string must exert the same force. We have the action here, and at B should be the reaction force. According to third law, action should be equal to the reaction force. So the T chord forms the third law of motion. While summing up all forces along Y is a first law, and summing up all forces along X is the second law. That's why the three laws of Newton's are applied to this problem. So replacing again the value of the mass of the B. Mass B is, oh no, weight of the B is the mass times the gravity. So then replace that. Replace this one, these two terms or two elements. So we have the negative B, mass B, gravity, sine beta, plus T chord minus mu K, mass B, gravity, cosine beta. Equivalent to mass B, which is the mass of the block B, multiplied by the acceleration. Again, we don't know what is A, what is the acceleration. We don't know what is tension. This is again an equation with two variables. So leave this as equation 2. With nothing to worry, because we're already deriving the equation 1, and here comes the equation 2. So the two equations are simultaneous equations. So simultaneous, it's because that we have two equations with the same variable. Equation 1 contains a known of A and T chord, while equation 2 contains a known of A and T chord. So therefore, the two equations are simultaneous equations. Okay? Now applying our algebra. So the power of algebra is very important. We will use these two in order to what? In order to solve for T chord and the acceleration. So all you need to do is to do the elimination process. We have to eliminate one variable at a time. So in this case, there are two variables, T chord and T. So we need to eliminate either acceleration or T chord. Now in this case, with looking at this result, it is easily to eliminate T chord. Why? Because this is positive and this is negative and positive, and there is no coefficient. So we can simply do what? Elimination by addition. Okay? We have to use the elimination by addition. Add everything. So if we add this one, the T chord will be eliminated. So if T chord was eliminated, then therefore we can solve for A. So do the algebra. This must be subtracted here. Add. Because add. So whatever sign, the same sign. So this will become mass A G sin theta minus G MB sin G sin theta. While T chord is already cancelled, this one, everything should be put it here, and this one should be here, negative. Then equivalent to, this is the mass A of times acceleration plus the mass B times acceleration. These acceleration are the same. So therefore we can we can remove the grouping symbol. Okay, remove the grouping symbol. Then after that, look at the result. We have only one unknown, and this is common, A. So we can take the common outside, leaving A quantity mass A plus B. So we will divide this both sides by this one. dividing this both sides. By the way, we have the common of the G, the gravitational acceleration. Take the common. So then what will happen is we can solve for A. So dividing both sides again by mass A plus mass B, this is the result. So we are done with calculating the acceleration. So all we need to do now is to substitute the values of A, the values of the given, so that we will, everything now are given. So we have the G, 9.8, the mass is 100, theta is 30, mass B is 50, beta is 53.1, mu K is 0.05, mass A again is 100, then mu K again the same. We have everything are given, mass A and mass B, 150. So therefore, substituting the values, we come up with the result of 0.274, and the unit is meter per second squared because it's the unit of the acceleration. So look at the result. The result provides a positive answer. What does it mean? Okay, this is the acceleration of blocks. But what is the meaning of this positive? Because there are cases that this will becomes negative. So what is the meaning of positive? Positive means our assumption of the block moves downward is correct, meaning the system moves towards the left. So in this case, we can say to answer letter A, which way will the block move when it releases? Then the answer is the system moves towards the left side, and our assumption is correct. Now, what will happen if our assumption is wrong? Suppose we assume it downward, means that block B moves down while B moves towards or up the plane, or maybe meaning the system will move towards right. So if it happens that we use that assumption, our result here becomes negative. So if it is negative, means our assumption is wrong. You have to reverse the direction. If the answer is 0, then the system is said to be in equilibrium. So therefore, our assumption is correct. This is the answer for letter B. Now, what is the answer for letter C? What's the tension in the cord? Okay? Now, we had already solved A. Look at equation 1 and equation 2. You can choose any of these two. Okay? You can choose any of these two to solve this equation. Equation 1 or equation 2, replace the acceleration here, then solve for T cord. Okay? So, let us say I will use equation 2. So, equation 2, this is in solving the tension in the cord. So, I will use this equation 2. So, I will substitute mass B, gravity beta, mu K, and so on. The only unknown is T cord because A is what? Was already calculated. So, we can replace that with the values. So, therefore, again, this is the mass of the block B. This is the acceleration. 53.1 as the angle beta. T cord is unknown. Friction is 0.05. Mass is 50. 53 point cosine. 53.1 cosine. Then and this acceleration is 0.274. We calculated that before. So therefore, the only unknown is T cord. So calculate, and the answer is T cord 407.45 Newton. And this is the tension in the cord. So therefore, these are the answers. By the way, what if this is negative? If T cord is negative, then your answer is wrong. You have to double check your solution because tension must be always, it will provide a positive answer. Why? Because we assume that negative. So therefore, the answer should be, means the tension in the cord is tend to move up the plane of block B. But in block B will tend, this will what? This will tend to move up also. So this is the action and this should be the reaction. So the amount of the force exerted by the string is 407.45 newtons. Okay? So these are the solutions to the double inclined system particle. Thank you. See you.